Okay.
So
So
rectangle dimensions, sir.
yeah, which dimension do you want? The
Outside.
rectangular dimension or the height?
Rectangle, sir.
Rectangle is of length 250 mm and width 200 mm.
And height is 35.
Yeah, height is 75, 75. Or 35, 75.
75.
Then you need to create a shape like this. You can create a rectangle here and give the fillets
Okay.
on these two sides. And also for this also you can give it like that. Now I'll give you the height for this one. Uh, height for this one will be 40. Okay, so from the top face to the bottom or the second face it will be 40 mm,
Okay.
and the height from this the second face to the third face will be 20 mm. Okay, so this is 40 and the bottom is 20. So total 60. Okay. So next we'll go into the file tab, click on new, select general setup, click OK. Now we already know the parameters, so we'll follow the same way. Okay.
Okay.
So first we need to define the workspace first. So come into the geometry view, double click on MCS fill, provide the distance for the axis. The height is of 75. So I'll give the Z axis of a distance 85. Because I am going to give face milling on the top side also. That is why I am giving 85. And now expand the MCS mill, double click on the workpiece, and you are going to specify the part. Then specify the blank since it is in the form of a rectangle. Select bounding block. Now give the distance in the positive Z direction as 10 because I have given it as 85, right?
Okay.
And I am giving an extra stock here of 10 mm. So that we need to remove that. Okay.
Okay.
So click OK. Now I can change the material here. Click OK. Now the workpiece has been defined. Next we need to create the tool. So click on create tool. Select the tool. I am going for the end mill itself. You can give the name nmill underscore D30. We'll start with the larger tool in pocket 1. Click OK. So the diameter is already set. It's given as 30. No need to change any other parameters.
Okay.
Only thing you can define is you can define the shank and also the holder. So I'll give an appropriate holder for this. So the tool has been defined. Now I'll create one more tool, same of the end mill type, and we'll be machining on this face. Okay, the inside face is here. And I'll give the location as pocket 2 and give the name nmill underscore D15. Okay, this will have a diameter of 15. Click OK, provide the diameter 15, type in the value, then define the shank. And the holder. Now you can also give it without a holder and shank, it is fine.
Okay.
But when you are doing it properly, you should give it. Okay.
Okay.
That is why I am insisting on doing this. Now there will be no error if you have not defined the shank or the holder. Okay.
Okay.
So the tools have been defined. Now next we need to go for create operation. So click on create operation. The first operation that we will do is the type is still mill planar. We need to change that.
Okay.
First we'll do an operation for floor and wall to remove the top face, and after that we'll go for floor and wall with IPW, or we can go with face milling with boundaries.
Okay.
Any of this is practical, and other options are all practical, but we'll be doing that in other cases, okay? In other models.
Okay.
So first we'll start with floor and wall. So select floor and wall, select the tool, that is the larger tool, nmill underscore D30, geometry is workpiece, method is mill. Click OK. Now the cut area floor. Okay, so click on the option to define the cut area floor and select the top face. Click OK. Now the top face has been selected. And one thing you need to do is you need to change the cut pattern. I'll go for zigzag, and you need to give the floor blank thickness. So that is currently given as 3 here. You need to change that to 10 because the floor blank thickness is 10, right? I had given an extra stock of 10 here. So I need to remove that. That is why I am giving the floor blank thickness as 10. And the depth per cut will be, I'll give it as 2. So for each pass, it will remove 2 mm of material. Now, if you want, you can define the width and speed. If you do not define it, that is also fine.
Okay.
Okay, I'm just giving the spindle speed as 3000 and clicking on this calculate button so that it calculates the surface speed and feet per tooth. So that is also defined. Now next, just click on generate. Now you will see the cutting pattern. Now if you want to reduce the cutting pattern, you can increase the maximum distance from, let's say, 50 to 75. And you'll see the difference. Or let's say 95. Okay, 95 will be fine, I think.
Okay.
Because the main thing to note here is that we need to reduce the machining time, right? So in order to effectively reduce the machining time, we need to adjust these values so that because we are using a bigger tool, and to cut using a bigger tool, it won't require many passes. Okay.
Okay.
So that is why I'm increasing the distance to 95 and just verify this. Okay.
Okay.
So it does the work efficiently without no problem. So that has been done. So click OK at the bottom. So the floor and wall has been defined. Next, we need to cut the inside parts, right? These two floors.
Yes, sir.
The second floor and the third floor. So again, click on create operation. Now I'm going to select this one, that is floor and wall with IPW. Now floor and wall, the first operation for floor and wall with IPW is more over the same operation, but the only difference is that you will be able to see the remaining material left behind or the uncut material. So IPW stands for in process workpiece. Okay.
Okay.
So in process workpiece meaning what this particular option does is it will show you the uncut material or the material that is left off, that is unmachined by the tool.
Okay.
So for that process you can use this, otherwise you can still go with the floor and wall, no matter. So I am going to select floor and wall with IPW for now and change it to a smaller tool. Geometry is workpiece, method is mill rough. Click OK. You need to define the same thing, cut area floor. So I'll select the cut area floor. Now when you are defining the cut area floor,
okay,
I'm going to select the second face, not the top face, because we have already done that, right?
Okay, sir.
So I need to select the second floor, that is this one, and you need to select the third one, right?
Yes.
Third floor also, right? So when you are selecting it, you need to make sure that once you have selected the second floor, you need to click on your middle mouse button or click on this button called add new set.
Okay.
Then only you should click on the third floor. Don't click on the second floor and third floor respectively together. Okay, like that. You should always select it as separate. So select the first floor or second floor, then click on add new set and select the third one.
Okay.
Okay, so you will see the list and it will have two sets.
Okay.
Okay. So that has been added. Now click OK. Now just change the cut patterns and everything. You can go with the follow part. Now the depth per cut is to be given. Depth per cut I will give it as 2, and you are not required. Now there is not an option called floor blank distance, right? In the other case we had seen the floor blank distance, but here there is no way to define it because it is not asking for it.
Okay.
Okay, so we do not need to know the total height of the floor plan in order to machine this. Okay, otherwise we should have known the height from the top face to the third floor here. Okay, so that should be the height given for the floor blank design. Now, since it is not required to give it here, no need to give it. Okay,
Okay.
now click on generate. Now you will see the cutting operation. Can you see? Are you able to generate it?
Yes, sir.
Okay, so you will get the tool path like this. Now here you will see an option to show you the resulting IPW. If you click on this, it will initially show the total workpiece material left behind, but once we machine it, we'll see it for ourselves. Okay,
Okay.
so just click on verify and click on play. See the machining process. So this is how the machining takes place. So it will start. So first it will cut the second floor up to the second floor, then it will move on to the third floor. Okay.
Okay.
Okay, now it is moving on to the third floor. So we will complete the operation like this. Okay.
Okay.
So that is the operation for floor and wall IPW. Okay.
Okay.
Now I am going to just come into the, you can either select the geometry view and you can see the floor and wall IPW second operation, right?
Okay.
Now just right click on that and just delete it for now. We'll move on to another operation. Okay.
Okay.
So just delete that. Now again click on create operation and go for the third operation, that is called face milling with boundaries. Okay.
Okay.
Now select that. Use the same tool, geometry is workpiece, method is mineral. Click OK. Now once you click OK, it will ask you to provide the face boundaries. Now you will not see a cut area, floor, or any option like that. You need to provide the boundary for the face. Okay.
Okay.
That is what it is asking for. So in this case, what I'm going to do is I need to provide the cut pattern. I'll change that to follow part. Then percentage of flat diameter is already given. Blank distance you need to define. So you need to know the blank distance. Okay. So that is required. Then the depth of cut. Then the final floor stock. How much stock that you want to leave on the bottom floor.
Okay.
Okay. So these are the things you can define here. So I'll just see what is the distance here. So come to analysis tab and just measure this from the top face to the third floor. Now this is kind of, let me see, simple distance of floor to this. It's 70 point something. Okay. So with that distance, what I'm going to do is click on create operation again. Select face milling with bound. So now we are going to define the face boundaries. So click on specify face boundaries. and you need to show the boundaries as in the same case. So select the first phase and click on add new set
Okay.
and select the third phase. Okay, so these needs to be selected separately. Okay, that you already know. So click OK. Now that is defined. Now we need to change the cut pattern to, let's say, follow part, and percentage flat diameter is 75. That we leave it as that. Flank distance we need to give. So I'm going to give it as 40. Depth of cut I will give it as 2, and the final floor stock,
Sir,
let's say I leave it
face
as
boundary once
5.
again.
Yeah.
Face
Hello.
boundary face boundary defining, sir, once again.
Face boundary, just click on this selector edit face boundary.
Okay.
As in the same case, we are selected. Select the second face, click on it. After that, click on add new set and select the third face. Same way that we have done in the previous operation.
Okay.
Okay, since that is defined, provide these values. The blank distance I'll give it as 40. The depth per cut I'll give it as 2, and the final floor stock I'll give it as 5. We'll see how it cuts again.
Blank distance means, sir?
Blank distance meaning the distance that is between the top face and the third floor here.
Top face and the 40.
Yeah. So that is almost approximately, I mean, it's giving us 70, but that is not accurate.
Okay.
It is somewhere near the 40, and I'll show you how we can identify that. So just give it 40 for now.
Okay.
And just generate this, we'll see. So once you generate this, you will see how it is cutting the material. Now, if you, for example, let's increase the blank distance to 43 and again generate it. Now, if you generate it to 43, if you increase the blank distance to 43, you will see how the cutting pattern will emerge. Can you see? So the cutting pattern will go to the top. Can you see? It is moving towards the top.
Okay.
So it's moving towards the top, but we do not have anything to cut here on the top, right?
Okay.
So it will be a wastage of a single cut on the top. So that is why I am giving it as 40. Because it will start cutting from the main material. Okay.
Okay.
Now if you just, I'll just show you. If I just click on play. Let's see. And just verify the second. Now it will start cutting. Okay, you can see. So it is still cutting and no material is being removed, right?
Yes, sir.
So you are just wasting a single pass by doing this.
Okay.
So only after the third pass that it will start cutting. Third or fourth pass, I think. So this is just unnecessary to basically waste the movement of the tool, or this just increases the machining time and it will not be efficient. So after the fourth or fifth pass, it starts cutting. Okay, that is why I am giving the blank distance as 40. So this is how you can understand what to give the blank distance.
Okay.
Okay. So if it starts cutting immediately, you can know that this is the optimum cutting position that you can give. Okay. If it's more than that, then it will be not efficient. So that is why I'm giving the blank distance from 43 to 40. Now if you click on generate and verify this, you'll see how it starts cutting. So you can see it will start cutting from the first pass.
Okay.
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 So this will cut it in this manner, you can see. So it's cutting the whole thing, and it will start cutting. It will leave this top, but it will remove it essentially. You can see. So what happened here is, you can see that on the edge here there is a bit of material left out, right on the sides. Right? Can you see?
Yes, sir.
On the side here and on the bottom floor here, there are still material left out. That is because I had given the floor stock as 5. That is why it's giving. So this thickness will be 5 mm.
Okay.
And also on the second floor also it will be 5 mm.
Okay.
And on the sides here, why it is creating it like this is because we are doing a roughening process, not a finishing process. That is why it's leaving leftover material on the sides.
Okay. Okay, sir.
So that is how this removes the material. So just click OK. Now we have done the face milling, but one more thing to do is that we need to remove the or finish the edges and the bottom face, right?
Yes, sir.
So in order to do that, we can use create operation again. Use the same tool itself and go for another operation called, let me see. Yeah, there can be, we can use 2 operations. So first I'll go with clean up corners. Okay,
Okay.
can you see this operation, clean up corners?
Clean up corners.
So this is a process used to remove material that is left behind by the operation. So this is essentially a finishing operation. Okay.
Clean up corner. Okay.
Can you see this operation?
Okay, sir.
So select that and change the method from mill rough to mill finish. Okay. Now we are going for the finishing process. Click OK. Now once you select that, you need to specify the part boundary. Then the floor, some more options are available. Let's see. First I'll define the face boundaries first. So first face, then the second face, then let me define the floor, then let me define the edges here. I'll tell you how we can do this, okay?
Okay.
Okay, now it will start cutting. Okay, so there are some more parameters there to define. Okay.
Okay.
So I'll tell you about that. Now how we can define, I'll show it one more time. So click on create operation.
Okay.
corners.
Okay.
Select the method as mill finish. Other than that, all the options are same. Click OK. Now first we need to define the part boundary. Okay.
Okay.
That is the boundary which are required to cut. Okay.
Okay.
So click on part boundary, and what you need to do is select the second face on the second floor. Then click on add new set again and select the third floor. Okay. So select those two as two different sets.
So
That is the first thing to do.
boundary geometry name here asking for me.
What?
For me, specify part boundary.
Yeah.
I click there. Then it's asking which one you part boundary, right?
Yeah. Select specify part boundaries.
So that one only I selected.
Just click on the symbol specify part boundaries.
Okay.
And it will ask you to select the boundaries.
But here showing
So selection.
another menu, different menu.
Could you show me yours? Okay, so this is because of the NX 11.
Okay, I click there.
That is fine. I'll show you how we can do that. So click on specify part boundaries.
Okay.
What you need to do is, no need to change anything there.
Okay.
Just click on the faces of that body. Can you show me the other side? Can you show the, yeah. So select the second face.
Okay.
Yeah, that one. And click on your middle mouse button. Then select the, okay, it is only allowing you to select single face. Okay. Just click on it again. I want to see. Custom calculator.
Here open close.
That you leave it. No need to change anything on that. But it's not telling you to. Can you click on that arrows? Yeah.
Which arrow, sir?
At the bottom there, you can
This
see
one.
arrows
Okay.
onto the left hand. Yeah. Click on that.
Yeah, nothing changed.
Okay, there's nothing to select. Let me see. Since it's not showing inside your case, just click on your middle scroll button itself.
Okay.
So it will come directly into this, right?
Yes, sir.
Okay, so then what you need to do is just click on specify part boundaries again.
Okay.
Just show me the model. So select the second face.
It's not selecting.
You are not able to select it, right?
Yes, sir.
So then click on cancel this and again open the operation. Yeah, cancel this also. Again open up create operation.
Okay.
Select clean up corners. Click OK. Click on part boundaries. Now select the second face. Then select the bottom face.
No need to click middle button.
Yeah, third face. Select the third face. Which one did you select? Select it again. I cannot see on the side. Can you move it? Move your mouse onto. So which of the two are selected? Yeah, just click on cancel.
Okay.
I didn't see what you did there. Just click on that dot symbol. It's not showing anything.
This face showing, sir, light color. Second face,
Yeah,
first
I'm not
face.
able to see that. Okay. Is it showing the second and third faces also?
No, only one face, first face only. Second face.
Okay, then we'll move with the. So now select the blank boundaries.
Blank boundaries. Okay.
Select the blank boundary and we need to change the mode from face to curve at the top.
Curve and edges.
Change it to curve and edges.
Okay.
And select the curves on the edge there.
Sorry?
On the model you can see the edges, the inside edges. Not that, yeah.
This one.
So start from the edge, the end side.
From
Yeah,
here.
from that end. Yeah. Okay. Now one thing, let me see. Don't click OK.
Okay.
Change the type from closed to open. Change it from closed to open and click OK. Okay, then click OK again. Okay, now that is it. Now click on the bottom option called specify floor. After specify trim boundaries, you will see specify floor.
Okay.
Specify, yeah, that one. Click on that and show the third face, third floor. You're not able to select it, right?
Yes, sir.
So what you need to do is, you need to change the option at the top there, not at invert. Can you see within work part, just
Go to
top of the plane option? Yeah, at the top. No need to cancel it.
Okay.
Could you see the toolbar there? No selection filter within work part. Can you see at the top, above plane option, above plane.
Okay. Here.
Yeah, within change that within work part. Change that to entire assembly.
Within work part only. Okay.
To entire assembly. Change it to entire assembly.
Entire assembly. Okay.
Yeah, now try to select the face. Okay, now you are able to select it. Click that.
Second one face.
No, third one.
Okay.
Okay, click on OK. Okay, then click OK and the options. Now just click on generate at the bottom. Let's see. It creates.
No material defined to cut around.
I think because of the face boundary, it might not be able to cut it. But in my case, it's correctly giving it. For some reason in your case, it's not being created. Okay, then we'll discuss that operation in the next class. Okay.
Okay.
Thank you. tell you about that in the next class. We'll leave it at that. Okay.
Okay, sir.
So I wanted to just show you. I'll just show you in mine. Okay.
Okay.
And tomorrow I'll tell you how you can do that in yours. Okay.
Okay, okay, sir.
So I'll share my screen. Okay. So I was just doing the operations itself. So I was first defining the phase boundary. So I have the option to select the phase boundary first. That is this one. Then click on add new set, or just click on your scroll button,
Okay.
and it will allow you to select the third phase also. So that is the case of, but in yours it might be different. That is why I'll tell you about that in next class. Okay.
Okay, sir.
So the part boundaries have been defined. Now I need to define the blank bound. Now blank boundaries is mainly the blank material that is being left out. Okay, we need to show where the blank material is left out. So select blank boundaries, and currently the blank boundaries are around here, right, in this area.
Corner.
So I'm not going to select face, I'm going to select curves,
Okay.
curves or edges, and select the curves from whichever manner you want. Select it like this, and after that you will see that this is for a closed boundary, but this is not a closed boundary, right? It's an open boundary.
Okay.
So change the boundary type from closed to open. Okay.
Okay.
Then click OK. So the blank boundary has been defined. Now you need to define the floor. Now the floor should be only the lowest most floor. Okay. The what do you say? The cutting position or the last face that you want to machine in should be shown as the floor. Okay.
Okay.
So in our case, we had to finish the second and also the third floor, but in this case, we should only show the lowermost floor. Okay.
Okay.
So select floor, specify floor, and click on the bottom floor here, and click OK. That has been selected. Now, what we need to do here is, when you come to the bottom here, you need to see an option called cut levels. That is where we define the depth of cut.
Okay.
Now click on cut levels and provide the depth of cut. And there are given as two options, which is given as a common depth of cut. I'll give it as 2, and the minimum depth of cut I'll give it as 1. Then click OK. Then click on generate. Now it will generate the cutting process. Okay.
Okay.
Now we'll see how this cuts. So okay, percentage and dimension and everything is minimum.
We
I need to change any
finishing operation only, sir, but it taking
yeah, this is taking
roughing and finishing also it taking or not? Number of passes more.
while which number of passes here are I mean it depends upon the software automatically calculates it based on the blank boundary and the floor.
Okay.
So it will cut up to the floor, not more than that.
Okay.
Okay. So if we click on verify, we will see how this cuts. So you can see, so it will remove the remaining material. Can you see?
Okay.
So it is going around. Now it is cutting some areas here, right, which is not required. It is only cutting the
Okay.
material that is left behind. So in some areas it is still cutting onto some position. So let me see, if I select profile and then generate this, it will be cutting this area, right? So okay, so 6 times it will be cutting like this. Solar periphery, and let me see the cutting parameters here. Now, in this case, it will cut the whole thing, and there are a lot of operations in between. So, this basic operation is meant for corners, but it will be removing the material from all the sides. Okay.
Okay.
But this is not the process that we want. I'm just showing you the process in which you can remove the material. Okay.
Okay.
There is one more operation we can do. There is another operation here called finish walls, finish floor, like that. There are some other options. So we'll come to that. Okay.
Okay.
So this was the operation that we did for floor and wall. Now next we'll move on to another operation called planar text. Okay.
Planar.
So I'll create another model. For this, I'll just close this for now, and I'll open up the model here for planar text. Let's see where is the model. I think we can do that on this face. Yeah. Okay. So now what we need to do here is, or it might be difficult. Wait, let me see one thing. After that, we'll come to planar text. Okay. Okay, so we can do this. Okay, I'll just show it. So you need to create a model like this first. Can you see?
Okay, sir.
Now this cutting of this rectangle here is a groove. Okay.
Okay.
Now I'll just show this rectangle has a total length of 200 and a width of 150. Length of 200 and width of 150. So first create that, and the height for this is 50. The height of this particular rectangle, bigger rectangle, is 50. I'll just come now, just create the model. Okay.
Okay, sir.
So the groove should come somewhere in the middle.
Okay.
Just draw a rectangle on this face. It should be middle to this, and a rectangle should be half side should be inside and half side should be outside.
Okay.
And its length can be, you can give it any length. I have given it here as 50 and 25. 50 is the length, 25 is the width.
Okay. Okay, sir. Created. Hello.